In this video, I'm going to introduce you to box plots. Box plots are sometimes called box and whisker plots. They're the same thing. A box plot is something that looks like this. It's a box. Somewhere it will have a vertical line, and there are two other lines coming out of it like this. Now, each of these 5 places on the box plot represent 5 different things. And what I'd like you to do is just copy this down into your books. And the first point always represents the minimum value. The last point always represents the maximum value. The middle point always represents the median. Where the box starts, that always represents the lower quartile. And where the box finishes, that always represents the upper quartile. So your teacher may wish to pause the video at this point so you can copy down that diagram and each of those arrows what they are pointing to. Now you may remember that where we've come across lower quartiles and upper quartiles and medians before is from drawing a cumulative frequency curve. And this box plot work is often tacked at the end of a cumulative frequency question. So what I'm going to do here is use a cumulative frequency curve that's already been drawn and just go through from there how we work out the different things to draw our box plot. So what we've got here is a cumulative frequency diagram representing the number of times taken, representing the times taken to run 1500 meters by each of the 240 members of the athletics club Western Harriers. You've got the time in minutes along the bottom. Now there's a break in the scale here. You see there's a little zigzag there. If I zoom in on that a minute, they haven't gone all the way down to 0. They're starting it off at 3.5 minutes, and they've got that zigzag there to show it. Up the side, we've got the cumulative frequency, and it's stopping at the 240 mark. So, quick reminder, to find the median, you always go halfway up. So there's a line actually put in here at half of 240. So this is the line to help us find the median. They've gone along to the curve and they've gone down. And the median value is this value here. Now, they actually in a minute will tell you exactly what that number is. That median actually works out at being, I think, the median one here works out at being about 5.25, something like that, 5.25 minutes. The lower quartile is a quarter of the way up. The other way of thinking is half of halfway up. If halfway up was 120, a quarter of the way up is 60. Come along, come down. This point here will represent the lower quartile, and that looks at about 4.7. Over here, the upper quartile, well, that's come from doing 3/4 of 240. And 3/4 of 240 is 180. Another way of doing that is adding together the 60 and the 120. That gives you 180. Come along, come down. That will give you the upper quartile. Well, we also know from here, as well as the lower quartile, the median and the upper quartile, the lowest value, the smallest value is this one here, which is at 3.5. And the longest time taken, if we come all the way down here, the longest time taken was, and if you bring it down, it's 7 minutes. So we got 5 pieces of information from this cumulative frequency graph. From this cumulative frequency graph, we know the minimum time was 3.5 minutes. We know the lower quartile from here is 4.7 minutes. We know the median here is at 5.3 minutes. We know the upper quartile here is at 5.7 minutes. And we know the maximum value is at 7 minutes. So what you would do in an exam is you'd probably have graph paper given to you, maybe often underneath this and with the same scale. Now I'm just going to sketch this out, but I'm going to have my time in minutes along here, and I'm going to try and use exactly the same scale as I've got here. 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7. Now when you do it, you do need to use squares in your book or graph paper and draw this out really accurately. Now going back to the diagram we had a minute ago, I need to put these markers on. Where the minimum value is, I put a point. Where the lower quartile is 4.7, I put a point. The median at 5.3, I put a point. The upper quartile at 5.7, I put a point. And the maximum at 7, I put a point. And then this is my box. And a line inside the box at the median. And I go down to the maximum and up to the maximum. So there I've got my box, and sometimes these are called the whiskers, which is why it's called a box and whisker plot. Now say those were times for the boys, we may find something different for the girls. So say that's a diagram for boys' times, this may be a diagram for girls' times. And I'm using exactly the same scale. So we'll call this the boys and this the girls. Once you've got two of these done and put them together on the same scale, you can make some comparisons. Who had the shortest running time? Boys. Okay, because theirs comes further over to the left than girls. Who had the longest running time? Boys. These came further out to the right. What can you say about the average for boys and girls? Well, the average for boys was there, that was their median. Average for girls is there, hardly anything in it. The medians are virtually the same. The girls have a slightly higher median, but on average they took slightly longer to run the 1500. What about the spread of the data? Well, the range for the boys was from 3.5 up to 7. So if I wanted to work out the range for the boys, I'll do 7, take away 3.5, and that's 3.5 minutes. That's the range for the boys. The girls, their smallest is 4, their biggest is maybe 6.3, 4 up to 6.3. So they have a range of 2.3 minutes. So that means the girls' times were closer together. They didn't have the extremely quick person, and they also didn't have the extremely slow person that the boys' group had. So that's one thing you can do when you draw them together. You can compare them. But the key thing is remembering what these 5 points represent. The minimum, the lower quartile, the median, the upper quartile, and the maximum. And often in questions, you may be given a cumulative frequency graph and be told to do a box plot. You may be given one box plot and given some values and told to draw another one, and you're often asked to compare. When you compare, look at the ranges. The boys' range was much wider than the girls' range. Look at the extremes, the minimum and the maximum. And look at the medians as well. Those are all things you could say. So for example, if you had a boys' chart which looked like that and a girls' chart which looked like that, don't really worry about whether you draw the line through there or not. Say that's boys, that's girls. Say these are test scores. What can you say about them? The highest mark was achieved by a girl, and the girl's highest mark looks considerably bigger than the boy's highest mark. Now you would actually need a scale on here somewhere, maybe 0 to 100. So you could say here that the girl's highest mark was in the 90s, the boy's highest mark was in the 80s. What about their averages? Well, on average, the girls are much higher scoring than the boys. The boys' average is about 50, the girls' average may be about 60. What about the range of marks, the spread? Well, if you measure it off, the boys' spread, if you use your pen, goes from all the length virtually of that blue bit of the pen. The girls, about the same. So it's about the same spread of marks, but generally the girls' marks are higher than the boys' marks. That's the sort of thing you can do by comparing box plots. Now what will happen is your teacher will give you a worksheet. Can you work through that sheet sensibly, please?